Hey, what's going on, guys? Against here. Well, first of all, I'd like to thank all of you guys for actually watching my BITBOARD Chess Engine in C series. Out of my got 95 videos here, right? And the reason why this video is about to appear here on YouTube is because many of you guys actually asking me about something is going wrong with the perf testing, right? So recently I got this email from NoPlace. So NoPlace, thank you, man. Thanks for giving this sort of an idea to make a video on this finally. So probably should make a video answering this because the questions are the same and the steps to walk through in order to resolve this kind of issues are really the same. So before we start, I'm sorry guys, before we start, just let me to highlight the general issue with this sort of questions like King, I've been following your tutorial in another programming language. Most likely this happens when someone is following the tutorial in another language, like porting to Python or Rust or whatever else language. In that case, there are more opportunities to make a mistake or a typo or produce a bug related to the programming language on its own, which you might not be aware of. So in this case, it happens quite often that you don't actually have the perf results in the chess engine that you're kind of like have been writing via porting what you've seen here in this BITBOARD Chess Engine series to the programming language of your choice, right? So this video generally is intended to answer the question how to go with the debugging of a chess engine, how to work with PERFT, and what steps to make in order to reveal the actual issue, so where the issue is within the code, because this is what makes you a chess programmer when you can reveal that sort of a bug on your own. Because again, like just to answer this sort of a question once and forever, so things like, could you please have a look at my code and kindly point me out where I was wrong, is literally the same as, could you please write my engine absolutely from scratch and then find where I made that sort of a mistake. So that's absolutely the same kind of ask, right? Absolutely the same. So without walking through your code absolutely from scratch, I can help you guys revealing that sort of a potential place where the bug might occur. So as far as I'm not capable of walking through everyone's source code to kind of like reveal those potential bugs. I would now try to walk through the code of my BBC Chess Engine and show and point out the most important thing, the most important places where the bugs may potentially occur. Okay, and also trying to give the hints along the way on how to fix those sorts of things. So I don't know, probably this video might be treated as some sort of a tutorial. So I'll show you how I personally doing this. Okay, so we'll need two things to consider. The first one is the BBC Chess Engine, which I've written here. Just as an example, instead of BBC, you can use the one you're porting to another language. You're following this sort of a series, so this is totally fine. You don't really need to do this with BBC, because BBC has perfect results and it's rated at CCRL above 2900, so it's not a problem in BBC, but it might be a problem in your engine. Okay. So, and another engine that I would be using to make sure that the perf results are going perfectly well would be Stockfish, because it's like the strongest, the most famous one, and probably the easiest one to use because they have the embedded perf feature into the engine itself. So you can use the UCI interface in order to actually being able to run this perf test directly from the command line. So without further ado, let's actually start. So there are two ways to download Stockfish. You can go to the official site and download the binary executable for whatever operating system you're working on, you're currently on. but I prefer to compile things on my own, so I can simply search for official Stockfish, and I just need to download this. So I just clone the code, and sorry, all my Korean stuff. By the way, I've started teaching Korean people how to talk in English recently. A very interesting thing. Unfortunately, no one really cares about this, but okay, I'm not complaining at any point. Just an excuse why so many things on my desktop here. Okay, so I can simply say git clone and then the path, and now it starts cloning Stockfish. And yeah, and also we will need, by the time it's working, we also need BBC. So let me just open a new tab here, and my BBC is here. Here it is. Okay, so same thing. I just want to clone this. Okay, good. I could not close the terminal. Okay, so git clone, and now just another path. So here we go. Okay, perfect. So yeah, okay. Okay, awesome. So now let's try to compile both. So we'll start with compiling Stockfish. If I only could remember how exactly this is done, but probably it would now tell me, give me some hints at the very least. So let's try let's try this one. Okay, and paste, and here we go. Yeah, it would now download the latest efficiently updatable neural network that we don't really need for perf testing, but let it just go in for this. At very least we'll have a working Stockfish out there. Okay, by the time it's downloading, I just want to go to the chess programming, and we now need perf results just to get some test positions for our perf test, starting from the initial one and then going through all the rest. So you can pick whatever you want. All should be you should get you need to make sure that you get the proper values for all this sort of for all the depths, right? Okay, so at the moment it should already be fine. So can I run Stockfish? Is this how the binary executable? Yeah. So here is our Stockfish. Yeah, let's just clear the console slide a little bit. No, sorry, it's quit. So let's clear, and here is the first working space. So Stockfish here, and I will leave this as is for now. And now let's go to BBC, and well, we could have used some existing binary version, by the way, but yeah, let's actually go and compile it. So it's just would be not gonna be faster, but yeah, let's just. Oh, I have one. It feels like open a terminal. Is this one? Oh yeah, this one should be. This one should be. Oh yeah, I'm sorry guys. Obviously, yeah. I just don't have this UCI this perf feature being embedded into the BBC. So we'll now alter the source code. And yeah, by the way, it would be a good idea to show how you can use BBC for comparing the perf results with your engine as well. So this might be another potentially interesting thing. Well, I think that actually I should embed this sort of a feature to make it available from as the UCI command. And probably, yeah, why not to do this, by the way? Why not to do this? So quit. So okay, go. And where do we parse? Do we parse the go command? parse go? Well, let's say, so hold on a sec, guys. I just want to improve the code slightly a bit. So let's say run perft, and if argument equals to, no, it's not, shouldn't be here. Should be where the fixed depth is. Yeah, because the code would be the same. Okay, so slightly a bit different. So here we want to run perft at given depth, right? So if perft here, so this would be like go perft and then the depth. So here we have our depth, and we can simply say, so run perft, okay, and perf test at the depth of depth, right, like this. Okay, this should be okay, and then we want to return from this because we're not gonna be searching, right? Search position, yeah, so I just want to return from here. This is the void function, so we can just say return, and this should be now working, hopefully. So let's compile and run the code, make and BBC. Okay. Well, to be honest, I didn't test this before, but now this should be really similar to how it's done in Stockfish. Okay, so we are in, not yet. Okay. Okay, so yeah, it would have been nice to add the print board function as well. By the way, I just thought that this is gonna be a good idea as well. Sorry guys, so as far as I would never ever come to update the source code in within some different circumstances. So let me just do this currently. So let's say so if the command, so here, so print board for debugging purposes, okay, so we can simply say like wait, does it actually create, I'm sorry, let me just adjust the view for this kind of thing. Yeah, it produces the executable file as well. And if I don't have git ignore, do I have git ignore here? I'm not sure. Okay, so here I can say else if, and so this would be, oh, sorry guys, and another thing until I forget that, so it's not +6, it's 1 2 3 4 5 and space 6, 1 2 3 4 5 space 6. Well, no, it's gonna be working. Yeah, because the length of the word perf and depth is the same. The depth parser should be working, but yeah, I really needed to check that out. Okay, so now let's say I don't know, board, or well, in Stockfish they use just the P. Okay, or I don't know how to call this. let's call it board. So 1, 2, 3, 4, 5 characters to compare, and here I just want to say print board, and actually this should be enough. Okay, and just to give a user an idea that this is available, so UCI loop, where is the main function? Well, it doesn't have that. Oh, it only goes on UCI command. Okay, so maybe before anything else, here let's say print user defined options. So printf and use go perft 5 to run perf test at current position at the depth of 5. And the new line here, and also here let's say use, let's say type, and here type board to print current board position. Okay, this should be first one, and I'm not sure if it's probably not initialized by default. Yeah, let's just make debug to make it a bit faster. Okay, and then I'll make this for production. Okay, so type board to print current position. So yeah, we can narrow this to let's say extended UCI commands, let's say extended commands for debugging. Okay, and the new line, and here let's say board. This would print current board position, go perft we'll run perf test. Okay. Okay. I know, guys, I should have been done this before recording this video, but yeah, just okay. Extended commands for debugging, and also here I want another new line, but it's not significant. Okay, so board, and we have the empty board because we didn't yet initialize anything. So if we say now position FEN, and then just grab a sort of an FEN, copy, and just paste this in, and now yeah, it prints the board by default, so we can use board again to see what kind of board we have in particular. Yeah, by the way, just to avoid this sort of annoyance, yeah, we can. So let me just search for all the print board occurrences. Okay. So where this happens. So let me just comment this out. Oh, this feels a little bit strange, but let's try again. Okay. So position, FEN, bring this one in. Okay, and now let's bring the board. So yeah, now we got the board here. Well, but what do we have in Stockfish? Maybe just to mimic the behavior of Stockfish. So that is probably, nope, not print. Board. Oh, come on. Let's have a look at the source code. I'm sorry guys, I just totally forgot how this is done in Stockfish. Did they remove this? This is weird. It should be in UCI. Something related to debugging. Also, some additional debug commands are supported. Stop, quit. Oh, D. No, D is for evaluation. Yeah, additional custom non-UCI commands, mainly for debugging. So flip, bench, compiler and position. D. That's probably stands for debug. Yeah, so this should be D. Yeah, and here Stockfish actually prints the position. Yeah, so let's make it as in Stockfish just to avoid any confusions. Let's make it the same. So I can simply say like so instead of board, let's use this D1, save, and here we can say D, print current board position, go perft, and the depth will run perft at the current position or the depth of 5. Say, okay, so I hope we can now start working this out. So yeah, let's quit from Stockfish for a while. Let's get back to BBC and let's make with the optimizations to make the perf faster. Okay. All right. Okay, so we have nothing. Now we have position, FEN, and let's have a look at the board. Sorry, D again. So we have this board here, and then we can do the same thing with the Stockfish. Okay, so we just run the Stockfish. Stockfish does initialize the board already by default. Well, this is optional. It's left for like implementation dependent, so you can do it however you want. There are no standards for this because anyway, when the GUI sends the initial command to your engine, it would explicitly should explicitly say like position start pass, and position start pass actually does initialize the engine's position to this sort of initial position, right? Okay, and now here let's say go perf, let's say 5, and we have the perf test running here. We have the number of nodes, and now absolutely the same should be available in BBC. Well, it's slower definitely, but the number of nodes 486, 560909, it's the same. Yeah, Stockfish doesn't print the time taken. I believe this is possible to do somehow if you use the bench command. That is possible. I even made a video once on how that can actually be done. Well, actually, hold on a sec, guys. I think we can have a look at this. So yeah, bench. Go bench perft. I don't really remember how exactly. Well, that is possible. I just don't remember currently. Again, I made a video on how to bring the time as well, but well, it's seen visually. Okay, guys, just hold on a sec. I really need to find this because yeah, it's essential to this video. Hold on a sec, please. Okay, so here is the video. The bench. And did it specify the commands? Yeah, this is it. So transposition table, hash size, something else like this, and then so if I just say, so nope, it's not that one. So for Stockfish, let's say current and the perf. So let's say depth 5 and then current and then the perf. Now it's the same, but it also prints the time that has been spent. Okay, so you can use this command as well, or say depth 4. Okay, so bench, then this one like sorry guys, I just don't remember exactly. So, well, maybe the description shows this specific position. This means yeah, 1 megabyte transposition tables, transposition hash table size, and 1 thread. Okay, so yeah, this is what this 2 ones means, and this is so funny. Yeah, to reference your own video when when kind of making this. Yeah, this is really fun. But again, like if it's not the matter of performance, but the matter of just a pure, like accuracy of the mode generator, just simply saying go perft like 5 is literally enough, because you have the number of nodes being searched and you can make use of that. And now the idea is the following. So let's now go for a different position. Let's take this one famous called CALIBRATE. Okay. So I just copy this one, and again, like if you want to switch to new position, you can simply use this UCI command position, start pause, and then paste this stuff in, and D to C. What? Are you kidding me? Did I say position start pause? I need to say position FEN. And yeah, now to make sure that the position has been initialized properly. And now let's say go depth 3, okay? No, go depth 3, go perf 3. Sorry guys, go perf 3. So here is the number of nodes, and we have this node count here. And now let's do the same for the engine we're interested in. So we can say position FEN, base the FEN. Let's print the board. Okay, and now we can say just go perf and 3, and what? Oh, I just misspelled the perf. Sorry guys, I'm so sorry. It went to a bit of a weird mode. Okay, let's wait a bit more until it compiles. Let's compile again. I could have just run BBC without running make. Okay, and we are very close to the issue definition of of this sort of a why my perf test is not perfectly accurate. Okay. Okay, so let's say position FEN and paste this one, and print the board to make sure that it has been updated. So go perf 3, and we have this sort of absolutely the same results. And well, obviously the move order in Stockfish in the engine that you're developing would have been different. Well, mostly because Stockfish has a way better move ordering than your engine has. Well, by the way, it's not even the case apparently. Does it go without move ordering here instead? Yeah, it seems like. Well, but anyway, it doesn't matter. It doesn't matter really. It's not really that kind of like easy way to compare manually. So pick up move, say D5, D6, and now I need to find D5, D6 here, and now I need to compare the number of nodes. So 991 here. So let me just make this smaller. Okay. So we have this. We have this D5, D6, 1991, D5, D6, 1991. And then compare in this sort of a way, try to compare all the moves, right? And if you have a bug in your engine, some of this, well, let's say you don't have a bug at depth number 1, depth number 2, and then at say at depth number 3, you have a bug. So let's say you forgot to update the impedance square for instance. Yeah, so let's go to the make move function and make move and just disable the impedance square, just to give you an idea that. So if pawn moved, where is the impedance square? Yeah, handle impedance captures. So let's say we ignore this. So we did some horrible bug within the impedance square, move handling within the make move function, right? So now let's try to. So this is BBC, right? So let's try to compile and run it again. And now the number of nodes would not be the same. And I just want to show you how to actually go for this sort of a debugging this sort of a debugging process, right? Yeah, the main thing is not to forget to uncomment this back. So position FEN, and I bring the position in. Okay, let's have a look and go perft 5. And now, well, I didn't want. Why did I go perf 5? I needed to go perf 3. But anyway, this would be this would be kind of different. Well, I can still demonstrate you this, by the way. So let's go perf 5 here as well. This would be much faster. Yeah, Stockfish rules. So this is the number of nodes that should be available. We're not going to hit this sort of a number of nodes because we've just disabled the impedance handling within the BBC chess engine. So I hope that makes sense. Okay. Okay, and as you can see, they no longer match. And if you have this sort of an issue, you need to downgrade the depth until you actually have exactly the same results. But I would done this from the opposite. I would done this from starting to go depth, say 1, and not go so good. Sorry, go perf. I keep forgetting this. So go perf 1, and we have 48 nodes, and then here we say go perf 1. We have oh, that's because nodes. Yeah, I also need to reset the nodes every time. Sorry guys, another little thing to upgrade in BBC, so just not to forget this ever. So let's go to the perf test. So we need to reset nodes count here, and nodes is a global variable. So nodes equals to 0. So here is the deal. Currently, yeah, that's a little bit of an issue. So currently it was gonna add in the nodes from the previous attempts. Let's say now it should be it should not be doing that. Yeah, I would never I would never reveal this code otherwise, guys, if only you didn't ask me to. So position fen and paste the position. Okay, and let's say go depth 3. No, not go perft 3. So we have do we still have the same? I don't even remember. But anyway, it's not what I want to test now. So let's say go perft 1. It should be 48. Yeah, so now the number of nodes is getting updated properly. So that's what I wanted to say. Okay, so from now on, so we do start from the depth 1. So we have 48 nodes. So everything is okay so far. Then we say go depth 2. Sorry, go perft. I'm sorry, guys. Go perft 2. And here is the number of nodes, and here we can say go perft 2. So okay so far. Then we can say go perft 3, and here go perft 3. Yeah, still okay, but at perf 4 it would be different now. So go perft 4, and here go perft 4. And you see, like, it's already different. So 4085601, 4085603. So now it's already different because I've changed the impedance square. And if we say we go further on, like go depth 5, well, it would take ages for BBC to complete, but you've seen that the numbers were completely different. So starting from this case, when we have the different numbers for the nodes, we can already start manually comparing every single move and the respective number of nodes here and here. Well, it's a pain to do manually, so what I've been doing back in the day, I've been writing some I created a Python script on the go to parse all of this stuff and to compare this manually. So you just can, I don't know, write this to file and then read this from file and then just create a data set from this and write some Python automation script to compare the results. I don't know if I could have shown you this, well, maybe in some separate video, not in this one. So if you're interested, guys, in watching the video how to write a Python script to automate the process of this kind of like perf result comparison, probably just let me know in the commentaries. If I have some time, I'll probably go for that. But when I've been, it's not essential. So when I've been doing this, I didn't, at the time when I was initially debugging my perf back in the day, I didn't know how to code in Python. So I was doing everything like manually. And currently, so just to give you an idea which move should be result in the issue, because I already know the move, and the move, let me just, that's the impedance related move, so let's just say D. So it's probably A2 to A4 results in a different number of nodes because we don't have this impedance capture, so it shouldn't be, there should be some issue with that. So I think that the move A to H4 should result in the different number of nodes. So let's try to search for A to A4. Again, when you're writing chess engines for years, it starts getting really intuitive. And even by the number of nodes you're getting, you can get already, how to call this, kind of guess where the issue might be. Okay, so A2 to A4. Where is the A2 to A4? A1. Oh, come on. Do I have the A2? A2 to A4. This is it. So 90978 and A2 to A4 here. So A2 to A4. Yeah, this is hell really, but actually many chess programmers do this. A2. Whoa, it's still the same. I'm surprised to say at least. I'm really surprised, guys. So okay, let's just again like so here. So what did I disable actually? So even peasant captures, so it doesn't erase the pawn. Oh, it doesn't erase the pawn at very least. So if it doesn't erase the pawn after the okay, so if it doesn't erase the pawn after the in peasant capture occurs, so this probably on B2 to B3. Maybe B2 to B3. Yeah, it's a little bit of a guessing, and I'm just really sorry for this, but let me just try to figure out with this B2 B3. No, it seems to be the proper value as well. B2 B3, yes, also correct. Okay, guys, so yeah, we really just need to manually compare E1 to F1, E1. Also the same to D1 to the 9. So the castling moves, yeah, they should be. Oh, maybe C3 to maybe knight gets captured apparently. C3. Maybe this. Okay, so C3 B1, this one, C3 B1, okay, C3 A4, same, C3 B1, hold on, C3 D1, C3 A4, 47, yeah, these are the same. C3 A4, C3 B5, also the same. Well, guys, I swear some of these values actually have a different number of nodes, because we have 2 nodes more here compared as opposed to here, right? So 01 and here 03. The difference might be much bigger, obviously, and yeah, I just thought that even if I know this, the move, the results, the issue, I thought that I can't. Well, I can't. Sorry for that. So you just need to either to manually check all of these moves to reveal the one result in the issue, or write again like some automating script to do this for you, basically. So, oh man, guys, if you could only know how I don't want to do this. Well, probably, hold on, there might be a slight alternative. Okay. Now or never. So, let's say perft.py. So let's say Stockfish and BBC and well, let's go some sort of copy. Compromise apparently. It's not the fastest way. Just pause the video. Hold on. Or even I can go for a completely different way. So I don't need to create, I can make them just plain strings for now. I can make them plain strings and parse manually. Save, and here copy. Oh, this was Stockfish, by the way. Okay, and no, is it on my desktop? Right. So running the file, and so the first thing I would put this file. Let's call this, okay, let's call this just perf example, perf debug, like this. Let's put this in. So let's give it a quick description. So example script to debug PERFT results. So you need to paste PERFT results from your engine and Stockfish to the variables, to the below variables, the variables below. Okay, to make it work for your own PERFT results, save. So here, let's say your engine results at given depth, and here Stockfish PERFT results and the same depth as your engine, obviously. Okay, and now let's just parse this. I want to parse results. So let's say print BBC dot split by the new line, and I'll use the list comprehension to Forgot, guys, I forgot how to append key value pair to Python dictionary. There is a function, some function there. Update, yeah. So let's go with BBC raw. Let's call it SF raw, and let's call this one BBC. And here we can say BBC dot update, and for move in this stuff, and update this, so move split by colon, and we want the first, and here we want the last. And if I did everything properly, no, I can't even. Parsed results. Let's call them data sets. Okay, and let's print the BBC one. So I now hope to get a dictionary, so I can use. So no, it's just okay. Let's just open a new terminal. Python 3 perft debug.py. Dictionary has now split. Okay, let's go step by step. I was a bit too fast, so now every move should be, are you kidding me, 117. Oh, BBC raw. Yeah, so this should be now working. Okay, sorry. So BBC raw, obviously. BBC raw, save. Okay. Okay, something's still not clear to me. Let's print this one. Okay, so we need to start with, so we need to get rid of this, guys. And just to keep the format, we can say, so from 1 to -1. Okay. Oh, so let's split by the move. Yeah, I just want to, so for BBC we need to split by the move. And take the first and to strip it, and here to take the second and to strip it as well. Man, are you kidding me? Come on. Okay, so let's just you must be kidding me. Okay, guys, I'm so sick and tired of programming. If you could only imagine how much I am. Okay. Yeah, that's because, okay. Oh, what have I done? So I can take just 1, 2, just the force of this. Yeah, so I can simply say one, and let's go for this one. Actually, the last one. Are you kidding me? Oh, I hate this. What's going wrong? Come on. Why do you mean the list index is out of range? It shouldn't be. Okay, so it occurs here. So let's have a look. Just don't understand why it's not available. This is so weird. Doesn't it have for okay, guys, sorry, I just paused the video because yeah, it starts annoying me significantly. Hold on a sec. Okay, now it seems to be better. So I just misplaced this index, and it should revert obviously to the splitted data, not to the entire sort of a dictionary. And also moved print here, so now it should be like 2, 1. Okay, and 4. I'm sorry, 3. Okay, so copy, paste. Okay, and I'll finally make this bbc.update. and print. Okay. Okay, good. So we just done the parsing for BBC. So now let's do the same for Stockfish results. So paste. Just change this to SF. And the indexing would be different. So this would be, so here we want to split by like this, and 0 split by like this, and -1, and print the SF. So it's a very simple script. Okay. And so the order is not the same, I believe. Yeah, and now the very last thing is to I want to sort dictionary keys in Python. Well, hold on a sec. If I just use JSON dumps for this purpose, so import packages, import JSON module. So import JSON. Import JSON, and now, so let's try JSON.dumps and BBC indent equals to, let's say, 2 spaces, and sort keys equals to true. Okay, so starting from A1 and then all this stuff, and if we just go to SF, we should be getting absolutely the same. Okay, perfect. And finally, we want to write comparison to file, to files. So I'm just wondering what would be the better way of doing this. So let's say for move in range from 0 to the length of, say, SF keys. Let's print the move. So the move is now indexed. Well, actually, it's actually index. Should give the indices. You kidding me? Oh, land keys like this. 47. Okay, and yeah, by the way, it also might happen that the initial amount is not the same. Okay, so to be honest, I don't remember how I did this before. So let's say I just want to print the length of sf.keys and of BBC key. So it's the matter of how many entries, so how many moves we have in. Well, we would now probably have the same. Are you kidding me? what's kind of wrong? You must be kidding me. What's going wrong here? Come on. Oh, guys, sorry for this crap. I think now you understand why I'm getting annoyed answering these questions all the time, especially for free. Yeah. What kind of indentation error? So am I totally blind? So both have 48 entries inside, which is good news, but it might not always be the case. So I just wanted to loop over the range of these keys, but it would only work in case if they are the same. If they are not the same, it's not going to be working. So I'm just wondering, well, we could have split this into two files. I just don't know how to. It would be the better way. Okay, let's go the most dumb way possible. So let's say for key and value in SF or in BBC dot items, and just want to print key and then value. So that's the way how to sort. Oh man, you must be kidding me. Key plus okay, and the same for SF. Oh man, did they not the same still? A2, A3. Oh, well, that's because yeah, I didn't. So one intermediate step. So this is not working because I didn't sort keys in this case. So JSON dumps BBC. Well, actually, I don't even need the indentation, so just sort keys equals to true, and then JSON loads and this stuff. And if I did everything correctly, it should put them in order. Okay, A1, C1, D1 ends with H2, and if now we do the same for Stockfish, yeah, now the order is the same. Good, thank God. Okay, so let's say order moves, and here, yeah, probably write them to different files is okay. So let's say with open sf.txt. We want to write to the file stream as, let's call it sf. So sf.write this, and plus the new line at the end, don't forget. So write sf.txt, and now also write, well, I'll start with BBC. The name for a file stream to make it different. Let's make it like this. Or let's say like this. BF, almost like the name of the esoteric programming language. Okay. So for key value in BBC items, for key value in Stockfish items, here. So now this should create two new files. You kidding me? Let's say, okay, F1, F2. Does Python allow numbers and variable names? Yeah, probably. Okay, and now it should create, yeah, here is the Stockfish TXT and here is the BBC TXT. So now we have two files. And you see, now if you just swap them, look over here, yeah? If you just quickly swapping this, you see that here is the move, so E2 to C4, so actually two moves, so this one, and also, oh, I'm sorry, why did I, and also this is the move that has a different result. Okay, so this move 34, but here we have 35, here we have 52, but here we have 51. So this is the noob's way of how to a bit automate the process of finding this sort of differences. I don't know, it would be a good idea to somehow merge this into a single data set. I stopped here, just to be honest. So I'll now show you how to deal with this sort of a thing. So this, okay. Oh man. So what else can we do? Yeah, this is the way how I did this. So I could have merged them if just make sure that they have the absolutely the same number of results. But if they don't, that's a little bit of an issue. So yeah, we can merge them only if they have the same. Okay, so probably, so let's say the number of root moves matches. So if the length of bbc.keys equals the length of Stockfish keys. So let's just first say print root moves number matches. Okay, and let's actually do this in the else clause. So here we can say numbers does not match. Please check BBC txt and sf.txt manually. Does manually one L, let it be. Oh, this drives me crazy, guys. Okay, manually typos 2L. Oh damn, manually. Okay, so otherwise it should fall here, but here we want to loop over the range of indices, let's say indexes. Okay, so for index in range from 0 to the len of sf dot, let's say keys, this is just fine, print index show. So we should be in this part of the code. Okay, and now we can make a new data set. So let's call it moves. So compare moves. Can still make them. Should this be a list? So let's say BBC. Oh man, it's not gonna be working like that. We can reference that by. What an unfortunate pain. So let's make them. Let's make them lists. Okay, everything goes them from scratch currently. So we append here. Well, this should be still working. Sprint. Why it starts from Z5 again? Oh. No, guys, sorry. So I don't go for this. That goes too complicated. That goes too complicated. Drop back. Just drop back. Okay, no, I just need to find a better way of how to compare them. I can say, hold on a sec, I can say BBC dot yeah, I can print. Okay, hold on a sec, this is how it's done. Okay, so sf dot keys, this is the list, and so it can be indexed by the index, right? And plus this, and then actually, yeah, so sf dot values dot values index plus BBC dot values index. You kidding me? What do you mean they don't support indexing? Okay, now we have the moves being compared finally. So can I spot the difference? Yeah, here is the difference. Here is the first difference and here is the second difference. Okay guys, so this works. So I would rather go for actually this kind of comparison. So now the only thing left to do here is to write this stuff to the file. So write comparison to file. So with open PERFT comparison.txt, we want to write to the file stream as file, and here, oh my god, did I do this finally? So I want to say f.write and then plus the new line character at the end. Okay, and before anything else, I want to, well, the moves can be done here, and here I can also say write headers. So f.write. So move is 4 characters, so I can say simply like move and then space. So the first one goes SF and then goes BBC. Now the only thing left is to say write in to so write in results. Okay, PERFT comparison, and yes, I need one extra space here. don't reload. Yeah, and here are our results. So it's just to prettify this a bit more. I can say like this. Okay, reload, and a new line. Okay, perfect. So yeah, one more. Okay, so here are the results, and now you can actually manually walk through all of this and find this one being run, find this one being run. Okay, guys, so I didn't really intend to write this sort of a piece of code here, yeah, but yeah, luckily we do have this now. So let's say the move E2 goes to C4. So here is the core technique that we need to use. So now we can say, so from this position, we need to make a move. The first move that results in an issue. So E2 to C4. So here, E2 goes to C4 here, right? E2 goes to C4. So we need to make this move on board. Oh my god, how to make this? So let's say, well, unfortunately BBC is not capable of generating the FEN from the position, so it's not that easy, but still I can show you this manually. So let's say position FEN, and then we go for this give repeat position copy. So go in here, paste, and now moves oh my god, D2 goes to C4 and hit enter, and let's have a look at the board again. Oh my god, didn't. Oh, it's probably, hold on a sec, position FEN. So let's just make it like so, and yeah, just the FEN should be completed for BBC. Not sure regarding Stockfish, probably as well. So moves, and D2 goes to C4. Let's have a look. You must be kidding me. Sorry guys. Maybe this move just doesn't exist. Hold on a sec. Just whatever values after, just to make the FEN completed, like the number of half moves in regards to 50 rule move count and the full move counter here. So oh, E2 to C4. I'm sorry, E2 to C4. It just was the wrong move. So E2 moves E2 to C4. Yeah, perfect. Now we have this bishop being placed on the right place, and now we need to say go perft, but this time reduce the depth. So we can say go perft. So we need to say go perft 4 apparently. Yeah, depth 4. So now we need to say go perf 3. And we have another list, okay? So we need to do the same in the Stockfish now. So we need to say position FEN, paste this in, put some values, and then say moves E2 to C4. Print the board, make sure that the bishop goes there, then say go depth 3, and no, sorry, go perf 3, go perf 3. Okay, and now we can repeat the steps. So I just copy this data, go into perf debug, and I want to update the stockfish raw, paste like this, and here I want to update the BBC data as well, so copy and then just paste it here, paste. So get rid of all this unnecessary spaces. Okay, save, and now we can run our results again. So perf debug, so number of moves still matches. Okay, go to perf comparison. Now we have different values, so now we need to find another issue. So still the same, and this one is not the same. So now we need to make the move C7 to C5 and reduce the depth. And I just, sorry guys, just put a note. So what moves did we make? So we did make the moves E2 to C4, and now we need to make moves C7 to C5 and reduce the depth. So let's go to Stockfish, say position, start, pause, get the link. So this is very, like, you need patience. If you want to go for chess programming, you need patience. Hope guys you now understand why I'm not doing this for you, because yeah, I know probably for a couple $100 per hour I would okay with debugging your engines, but otherwise it's not the case really. So I just copy this, go in here, no, not the start, pause, position FEN, and paste, and moves, and now the moves would be E2 to C4, C7 to C5, enter. Have a look at the position. Yeah, C5 pawn moves, and now say go perf 2 in this case. And here are our results. And now we need to actually, can I? Yeah, I can duplicate this one, copy, put it here. Okay, go perf 2. So every time I add the move, I do reduce the depth. And now I can make this again like one more time. So I copy the moves, going back to the Python, to the perf debug script. So BBC raw right over in here, and paste them in. Okay. This process can be automated as well. So everything I'm currently doing can be automated as well. But again, like, it's the matter of how deeply you're ready to go for this sort of an automation. I'm just trying to show the gist of the process. I never ever actually wanted to automate this that deeply. So now we have last nodes already, and I'll go for Stockfish results. Nope, it's not Stockfish results. Here are the Stockfish results. So here are the latest Stockfish results for PERFT. So copy and paste. Okay, save, and now we run our script again. So still the number of moves matches. So reload. So now it's okay. What? 47, 48. Let's say this one. So D5 to C6. D5 to C6 is being added. So copy this one, paste at D5 to C6, enter, and now go perf 1. And now finally the number of nodes here should be different in comparison to Stockfish. So we have 39 nodes, and and we now go to Stockfish, paste this stuff in. And D5 to C6 and go perft 1. So we do reduce the perft depth, and here we go. So we have like 40 nodes searched at the root root of the search, and here we have 39. So now we'll get into a different part copy of our into a different part of our script. So here I have the Stockfish part. So the Stockfish goes here, paste, okay, and now for BBC, take this, copy, and paste, okay. Save, and now when I run the script one more time, it should tell me that doesn't match. So please check bbc.txt at sf.txt manually. So now it creates two files, bbc.txt and stockfish.txt as well, and they should be the same, but here is the difference. So Stockfish has this, so which one is more? So this one, we have 40 in Stockfish, C5, and in BBC. Well, now we really need to check them manually. Well, actually, we could extend this script even more to find what the move in particular is doesn't exist. And when we see that move that doesn't exist, we can get an kind of idea of what can be run. So like what move. Well, by the way, already at this sort of a position, well, just, oh my god, guys, this is so boring. I know this is so boring. So D8, F8, C8. Seventeen. Yeah, and here is the move. So BBC, yeah, this is how I figure this out. So BBC doesn't have the move E7 to C5 in this position. So we would just reveal that. Okay, guys, for those purists, you can implement this on its own. You just make a few lines of Python code more to reveal the move that is not available in one list of these keys of the dictionary. So I'm just so tired and sick and tired of this, to be honest. I don't really want to go for this, but I just give you an idea, like manually, what's the gist here. You can also do this absolutely like I did back in the day without automating at all. So the move E7 to C5 is the move that is not made by BBC. So now we can finally go to the position, to this sort of a final position. So, I'm sorry, what have I done? Nope. I need this one. Copy and paste, run, and print the move. So in this sort of a position, there should be a move which is E7 to C5, E7 to C5, E7, E7, E7 to C5. Hold on a sec, is the position going to be the same? Stockfish, sorry guys, I just feel a little bit confused. Well, to be honest, I'm slightly a bit confused by the fact that the position is not the same. So C5. So here queen actually can go here, right? Oh yeah, well, that's the case. So the position is different because when in-peasant capture occurred, so yeah, this pawn probably captured in-peasant, yeah, and this pawn wasn't erased, so we have a different position. So here is how we can, well, by the way, is that true? So d5 to, hold on, d5 to c6, was it the last, yeah, this is it. Here, I got it here in my notes. Here, d5 to c6. So here is the deal, guys. So finally we can see. So we had a move, d5 goes to c6, and we have this pawn, which is absolutely wrong because it shouldn't be there. It should get erased. It should literally be captured with an in-peasant, right? But as far as we don't have that in our code, because we've commented out this part, this actually results in a wrong position. So this was a completed detective story. I understand it takes time and effort to figure out how this stuff can be done actually. So I really hope that's kind of clear and makes sense. So, but yeah, so here we did reveal position at the depth perf depth 1, where we literally have the different number of nodes being involved within kind of like different number of nodes being available at the root depth. So the number of root moves at the depth of 1 in a certain position is different, and this is the core issue. So here we see that we've just made an in-peasant move, but the pawn didn't disappear. So this gives us an idea, okay, so there should be something wrong with an in-peasant capture, right? And as far as there is something wrong with an in-peasant capture, then we need to have a look at the in-peasant capture. And now the most interesting question is where exactly to have a look at your source code at, and this might not only be like the matter of move generator, so in this case it's the matter of this part in make move function. So now we can uncomment this code back, save, and now I need, hold on guys, I'm sorry, I'm just recording this video for too long and my cats already want to eat and then going completely crazy torturing me. So yeah, I really need to feed them. My wife is out and she didn't do this, so I'm sorry guys. Okay, so now if I just go back to my BBC quip from here, and I just need this position, so I copy and I can probably run things again, and now this kind of bug that we've produced for this learning purposes has been resolved. So currently it should be fine in this position, and respectively it would be given the same kind of good results in another position. Okay, so I put this in, so let's have a look, and I say go perf 1, and we have 40 nodes, which is exactly the number of nodes that should be there. So go perf 1, we have this 40 nodes, and the moves are all kind of absolutely the same. Okay, so this is it regarding the testing on its own, right? So how to reveal this kind of position that result in a different number of root nodes, and then when you have a look at the certain move that has not been generated, based on that information, you can assume what in particular is going wrong within your chess engine. Again, like, this is just a matter of experience. So if you just write, I don't know, 5 chess engine at very least, and you will get used to it. You will start and just kind of feeling where the issue might be. So this is kind of it. And well, actually, let's go for one last test. So this kind of initial position, and go perf, let's say 4. So this is the number, and here go perf 4, and we have absolutely the same number here. So just to give you an idea that now works properly all the way along. So this number is the same as this one, right? So this is it. Now we can quit from here. Yeah, I will update the code all the way along. But before we end this sort of a video, yeah, close without saving. Before we end this sort of a video, one last thing to take care of. So, well, I would better show you this within the videos in this BITBOARD Chess Engine in C playlist rather than the source code, and you will now understand why exactly. So playlists and this one. So you guys often ask me like, what's wrong with my bitboards? And you say like, there is something wrong with my bitboards, so I probably made some mistake during importing the bitboards to a different programming language. This definitely might be the case, but in order to just to give you an idea why I don't answer, like if you ask me, please have a look at my code, I'm not going to be doing this ever, because in order to have a look at your code and to make and actually fix this sort of an issue, as I've been mentioning in the very beginning of this video, it's the matter of following the steps presented in all of these videos. So generate the magic numbers, do all this stuff, going for this bitboard masks, then initializing all this stuff, okay? And then so the first issue where the first place where the issue might occur is the matter of the slide and piece attack generation. So this is the first, but this is not the only place where the bug may occur. So it's only one possibility. So another possibility is the move generator itself. So let's say you might be wrong with kind of like implementing the castling rules or impasant rules, whatever. So that might be the issue as well. And then one of the most issues is within well, another place where it can occur. So encoding and decoding move, you just may be decoding the move run. So it's also might be the case. Also, I don't know. Probably you can not put the move into the move list, so whatever, basically. But one of the major issues, you might just be having the bug in the make move functions. And from my experience, personally, I can say that I would say 90% of the bugs where the perf is not kind of working comes from this make move function. So you really need to make sure that you actually do handle all the cases like castling, pawn promotion, in peasant square handling. What else? That you do handle captures properly. So when the piece is taken back, that the piece that has been captured has been restored on the original place properly. So make move is another place for bugs. So again, I guess just to give you an idea, the matter of answering the question, could you please help me to figure out where the bug in my code? I can't, because it's the matter I just need to write your entire engine absolutely from scratch, line by line. That's the only way how I can reveal where the bug is. And when you say like, I have exactly the same names for the functions and all this stuff, this means literally nothing to me, because it's not the matter of copy pasting the code or porting the code. It's not that. It's just a matter of understanding. So if you do this blindly without like precisely following this tutorial series, which explains every single step, like in the step-by-step mode, so you not only if you just copy the code, you're not going to learn anything. You really need to listen to the explanations and to precisely mimic that sort of a thing. But you also need to have a bit of understanding what are you actually doing. So this is just a matter of experience. So again, okay, so leaper attacks, slider piece attack generation with the magic bitboards being involved. the move generator function itself and the make move function. If you have the take back functions, that's another place where the bugs may occur. I didn't use take back for simplicity in BBC, but I have used that in my Chinese chess with Wukong.js, which is written in JavaScript and a bit more complicated. So yeah, that's kind of it. So you just need to be precise. And finally, I just want to end this video with probably the most important thought to share with you guys, that chess programming is not something like, sir, could you please fix this piece of code for me? If you go for this, you just better go and download Stockfish and enjoy it. And that's kind of it. So if you want to write the chess engine from scratch, it's not the matter of just taking someone else's code. It's the matter of working out every single part of the engine on its own, and just until you make sure that you do understand all these tiny little details. And the very last thing that I was saying in this video, so just to give an idea, do you know, guys, how many years did it take me to pass my very first perf test? It took me 3 years. Can you believe this? It took me 3 years to master chess programming at the level, so I could understand all the possible potential pitfalls where these issues in regards to perf tests might arise in. Okay, and that was a chess engine without BITBOARD, so that was the array-based. That was the array-based engine, ChanGlide or Changin. It should be somewhere in my GitHub and on my chess programming Wikipedia page as well. So just to give you an idea, 3 years, guys, 3 years it took me to come up with my own bug-free move generator. So it's okay if you can't pass the perf test in your first engine. So if you just want to play around with the search evaluation, just try to make it stronger, you can just download an existing move generator, whatever. You can even use the BBC one. You can use from the desired programming language you want to write the engine into, like Python, Rust, whatever, and then just go for implementing search and evaluation. But again, like, the idea behind this perf debugging is, it's something that needs really lots of accuracy. So you really need to dive inside deeply, for otherwise it's not going anywhere. So chess programming is like 99% of debugging and 1% of luck, I would say. So you just debug until you understand every single part. The more you debug, the more you understand how the things work. So that's the difference between the chess programmer and that guy who just copies the code and makes use of it. That's kind of it. So I want to, I forgot the word. I want to encourage you guys to go deep into chess programming and work out every tiny little thing. And it's okay if it takes kind of long to fix this sort of a thing. So the idea of this video is just to motivate you to go for your own sort of research, and I've just shown you the core technique that every chess programmer literally uses in order to debug his chess engine. So as soon as you find the position where the number of root moves is not matching, that's the position containing the actual issue, and by seeing how the position is different, you can get an idea of what have you actually done wrong. So this is it from my side, guys. I wish you to pass the perf test completely and master chess programming. So sorry for this video, it was a bit too long, and I have another idea. So probably, recently Harmgert Müller at talkchess.com actually proved the fact that array-based move generator can be as fast as the BITBOARD one. So this is a bit of a teaser for future. And the idea is that as far as no one actually using handcrafted evaluation in today's modern engine, and everyone is going for efficiently updatable neural networks, we don't actually need BITBOARDs at all, because mostly BITBOARDs is not only the matter of speed, but rather the matter of handcrafted evaluation to get the pawn structure, mobility, things like that. But if you use efficiently updatable neural network, in that case, BITBOARD starts getting a bit of a redundancy. So I currently think that the array-based approach is better. And again, like as far as this has been proved that it can be as fast as BITBOARDs, then I think this is definitely the way to go. So currently I would say that BITBOARD is a bit of a legacy in today's chess programming world. But again, like just to bring some proofs in regards to what I've just said, I just need to make a bit of research to find the actual move generator by Harm-Gert Müller to run the comparison, like the test, like how fast that node generator is compared to Stockfish, let's say compared to BBC and all this stuff, just to give you a visual proof of that sort of a concept. I'm not aware of all the tiny little tricks and details on how to speed that up. I just know the general concepts. I've never been doing that because I wasn't really interested in that. But again, like just as the matter of kind of proving all the concepts, so we can say that BITBOARDs that we can make the array-based generator that is as fast as BITBOARDs as well. So if you're extremely interested in having a look at those kind of results, perfect results, comparison, like array-based versus BITBOARD, where the array-based one is highly optimized, please leave the commentary in the description below this video. Okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.